Let us solve an interesting question on the relationship between own price elasticity of demand, income elasticity of demand, and cross price elasticity of demand. The question is, assume that a consumption basket of a utility maximizing consumer consists of only two goods, that is X and Y. Assume further that own price elasticity of demand for good X is minus 1.5 and income elasticity of demand for good X is 5. We have to find out the cross price elasticity of demand for good Y. That means how will the quantity demanded of good X change due to the change in the price of good Y. Okay, so let us see what we are being given. We are being given the own price elasticity of demand. Let's denote it by E subscript P. It is being given us as minus 1.5. Also cross price income elasticity of demand is being given. Let's denote it by E subscript M. It is being given us as 5. We have to find out the cross price elasticity of demand. Let's denote it by E subscript C. We have to find out this very stuff. Okay. So since consumer consumes only two goods X and Y, first we need to find out what is the demand function of good X here. Okay. So three things are here. We have the price of good X, price of good Y, and income. When we have three things here, that means the demand function for good X will be, let's denote it by, let us say X, the demand for good X is a function of three things, that is price of good X, comma, price of good Y, comma, income. Okay, we say quantity demanded of good X is a function of prices and income. When we have this kind of demand function, we say it is actually, let me see the proper color, it is actually the Marshallian demand function. Okay, so it is Marshallian demand function. We have the Marshallian demand function. One of the important property of the Marshallian demand function is Marshallian demand function is homogeneous of degree 0 in prices and income. Okay, so important property of the Marshallian demand function is that Marshallian demand function is homogeneous of degree 0 in prices, that is price of X, price of Y, and income. So we will solve this question, but we will understand other related concepts here. So let us first take this question aside and let us see what is meant by the homogeneous function. Okay, so by homogeneous function what we mean, color here. So by homogeneous function we say, let us suppose we have, let us take the relatable economical function here, that will make sense. Let us say I have a function that is f of k and l. Let us say this is the production function. Okay, I am saying this function f of kl is homogeneous of degree n, if, that means if both variables, that is capital, is increased by a factor lambda, and labor is also increased by the same factor, that is lambda, and if we get a function like this, that is lambda raised power n times the original function, that is f of kl, I am saying that this function f of kl is homogeneous of degree n. Okay, if we are in a situation that we can factor out this lambda from this function, and this n denotes the degree of homogeneity. Okay, so let us see an example here. Okay, let us suppose we have a function f of kl is equal to k plus l. Okay, so if I increase both factor capital and lambda by a factor, let us say lambda k times lambda l, so in place of k we have lambda k In place of L, we have lambda L. Because we have increased both the factors by the same fraction, by the same factor, we can take lambda common, and we are left with K plus L. And we know that K plus L is equal to f of KL. So I can write it like this: lambda raised power 1 f of KL. I am saying this function is homogeneous of degree 1, okay, because we are able to factor out lambda here, and we multiply it with the original function. So this is a homogeneous function of degree n, and it simply tells us that if we increase capital and labor by the same factor, output will also increase by the same factor. Okay, that is, if we double the units of capital and labor, our output will also get doubled, because here degree of homogeneity is equal to 1, and by n is equal to 1, homogeneous of degree 1, this function gives us constant returns to scale. So what about the 0 degree? Homogeneous of degree 0. Let us suppose we have another function f of KL. Okay, I'm just trying to take these capital and labor to make economic sense here. So let us say we have another function like this, K upon L. Okay, our output depends upon this ratio, capital and labor. Let us increase here both capital and labor by the same fraction, that is f of lambda K comma lambda L. So what will happen here? So K is increased by lambda, and L is also increased by lambda. So what will we get? Lambda will get cancelled, and can I rewrite it in this fashion? Lambda raised power 0, because lambda raised power 0 will be equal to 1 here. Lambda gets cancelled. We are left with K upon L, that is f of, this is our ordinal function, K upon L. So this function is homogeneous of degree 0. Okay, this is homogeneous of degree 0 here. Okay, that means if we increase both capital and labor by the same fraction, by the same proportion, output will not increase at all. Okay, output will remain same. Okay, now let's take this aside and come to the question. I am saying that this function, that is demand for good X, is a function of price of good X, price of good Y, and income. This is the Marshallian demand function, when a demand function is a function of prices and income. Okay, and one of the important property of this Marshallian demand function is it is homogeneous of degree 0 in prices and income. Now, if that is the case, then we apply the Euler's theorem here. Okay, we say according to the Euler's theorem. Okay, according to Euler's theorem here. Euler's theorem tells us that is, and let me write it here. One of the important property of the Euler's theorem is that if we, what we call, or let me write it here. So applying the Euler's theorem here, that tells us the derivative of demand function here, in this case, in this particular case, with respect to price of good X times price of good X plus the derivative of this demand function this time with respect to the price of good Y times price of good Y plus the derivative of the given demand function with respect to income times income is equal to n times the given demand function. Okay, that is, if we take the partial derivatives of the homogeneous function, then the sum of these partial derivatives and correspondingly multiplying with them the prices of X, Y, and M, it is actually equal to the n times the given demand function, and denotes the what we call here the degree of homogeneity. Since we know that n is equal to 0 here, so here since n is equal to 0, 0, then what will happen? So here we have n times, so in place of n we have 0. 0 times x will become 0. That gives us dx upon dpx. These are the partial derivatives obviously, times px plus dx upon dpy times py plus dx upon dm times m is equal to 0. Okay, if a function is homogeneous of degree 0, then the sum of these partial derivatives should be equal to 0. Okay, 0 times x is 0. Now what will we do? Let us do one thing here. Let's divide both sides by x here. Okay, let's divide both sides by x. So dividing this stuff by x, let's divide it here x. Let's divide it by x here. Let's divide it by x here. And similarly here, 0 divided by x will be equal to 0. Doing that very stuff, does this look similar? This has some implications here. What does exactly this first term tell us? It simply tells us change in the demand of good x due to the change in the price of this good x times the price of x upon quantity demanded of good x. This is actually the own price elasticity of demand. So can I write E subscript P here? Okay, plus similarly, let us see what does this expression, or rather this term tell us. It simply tells us change in the demand of good x due to the change in the price of another good, that is price of good y, times py upon x. So this is actually the cross price elasticity of demand. So can I write it like this, E subscript C, and here you can see this very stuff. What exactly is this? It simply tells us change in the demand of good x due to the change in income times income upon x. This is actually the income elasticity of demand. Let's denote it by E subscript M. It should be equal to 0. So the homogeneity condition states in this particular case, it says that the sum of own price elasticity of demand, cross price elasticity of demand, and income elasticity of demand is equal to 0 for a particular good, in this case which is x. Let me repeat it here. The homogeneity condition states that the sum of own and price elasticity of and the income elasticity for a particular good should be equal to 0. Okay, and the implication of this Marshallian demand function, when we say it is homogeneous of degree 0 in income and prices, what exactly is meant by this? It simply tells us if we multiply all prices and income by the same amount, demand will not change at all. Okay, so how do I explain it? Let us say if the price of good x was, let us say, $10, and income of the consumer was, let us say, $100, and let us say demand for good x was, that is income upon price, that is 100 upon 10, let us say 10 units were demanded. Let us suppose that income and prices are doubled here. Okay, so let us say price of good x has been doubled from 10 to 20. Income of the consumer has doubled also from 100 to 200. Then what will happen to the demand of good x? It will be equal to x will be equal to 200 upon 20, which is again 10, which simply tells us if we multiply all prices and income by the same amount, demand will not change at all. So we can imagine, if we take an intuition here, imagine government doubles all prices and also doubles our income. So there is no reason for us, to change our demand, as nothing really got cheaper here. And here you can see, and nor our income increased in real terms. Okay, so let's come to the question. So price elasticity of demand is, own price elasticity of demand is minus 1.5 plus cross price elasticity, which we need to find out, plus income elasticity of demand is being given us as 5. It should be equal to 0. That gives us Magenta's. So 5 minus 1.5, it comes out to be minus 3.5 plus cross price elasticity of demand should be equal to 0, which implies cross price elasticity of demand will be equal to, sorry, it is here plus 3.5. 5 minus 1.5 is 3 plus 3.5, so transposing it will become minus 3.5. okay, so it simply says if we take partial derivative of the Marshall in demand function with respect to price and income, and all these elasticities will equal to 0. And here we have seen this. I hope I make myself clear in this video. So you can see I am doing these stuff for free. I don't charge any penny for these questions. Okay, so I guess this is and this question or this kind of concept was not available on the YouTube, so I feel privileged that I have done some value addition for the YouTube community for free. Okay, so if you like these videos, please share, comment and subscribe this channel. That is only motivation for me to keep going on. Okay, I don't take any other stuff here. And thank you.